All right, welcome back. Please, if you can hear my voice, can you just say something? Can you hear me? Can you drop? Okay. All right. Robinson, welcome. Courage. All right. Sorry, this is the first time I'm actually going live. Solving past questions. So there's been a lot of changes on YouTube. Okay. So we're going to be solving past question from last year. The last year past questions. So I'll be writing it out on the board. Okay. So we have the first question here, which says, calculate the half-life of the first order equation with rate constant seven point zero times 10. Now you need to understand this particular topic is under chemical kinetics, all right? Now we are told that, remember, half-life for a first order reaction is always 0.693 all over K. This is a formula for half-life of a first order reaction, right? I wouldn't want to start telling us the half-life for zero order, second order. I already posted the video, so please do well to watch that particular video. Now, if you're asked to solve for half-life of a first order reaction, this is basically what you're going to do. 0.693 divided by K. Now, this K is a rate constant. So I'll come here, I'll simply say 0.693 divided by K. Now, what is the value of this? 7.0 times 10 raised to the power of minus 4. Please bear this at the back of your mind that in exams, they may not necessarily give you this first order, right? They might change it to zero order, second order. So take note of this, right? Of this formula. So when you actually do this, this is 0.693 divided by 7.0 times 10 raised to the power of minus 4. So the answer to this is 990 seconds. Please verify that with your calculator. Now we have the next question. Please, this is last year past question, 2024. All right. I will share the past question on the group after this class. Now, for those of us that have past question, you can check it out as well. Question number 2 says, the number of collision, please pay attention. The number of collision per second taking place between the reactant species is called what? The number of collision per seconds taking place between reactant species is dash. Now, class, the answer to this question is collision frequency. Remember, for every chemical reaction to occur, if I have A plus B, for these two to occur, this A must collide with B, right? You cannot actually have two things that you want to react to form a product without them coming together. So they're bound to collide, all right? So the number of times that they are going to collide is what we refer to as collision frequency, right? Now, listen, there's also what we call effective collision. Not all the collisions will give rise to a new product, right? The frequency or the number of times they will collide is what we call collision frequency. Now, that is the answer to that question. However, what is effective collision? We have effective collision and we also have ineffective collision. Now, a collision is said to be effective. The ones that will collide to form a product is what we refer to as effective collision. Remember, there's every possibility that 50 of A will collide with 50 of B, but not 50 of A and 50 of B will come together to form a product. So let's say 25 out of this can pick 25 out of this. The ones that will actually collide to form a product is what we refer to as effective collision. Just take note of that. Effective collision. Okay? Now, question number 3 says, the unit of a second order reaction is given to us as dash. The unit of a second order reaction. Sorry, let me get my duster. It says, now remember that we have different orders of reaction. We have first order, we have second order, we have third order. Okay, now what is the unit of a first order? I'm going to give us a general formula. All right, so the unit of orders of reaction is equals to mole per liters 1 minus n per second, where n equals to order of reaction. So if n equals to 0, that is 0 order. If n equals to 1, that is first order. If n equals to 2, that is second order. Now the question said the unit of second order reaction is given to us as that. So what you're simply going to do is anywhere you see n, you put 2 here. So this becomes mole per liters 1 minus 2 per seconds. Expand these brackets. Now this guy is having mole 1, so this is going to be per mole minus this becomes this. So this is the unit of a second order rate constant. If it were to be 0 order, if you put 0 here, 1 minus 0 is 1. You use 1 to evaluate everything. If you put here to be 1, 1 minus 1 is 0. So everything raised to the power of 0 is 1. 1 times this becomes this. So that is the order. This is the unit of a second order reaction. This is the answer. Please, if you have any question, you can drop it on the chat. I'll check it out. Okay, so let's look at question number 4. Please, important, and please don't just, this should be going into our heads directly. Remember, tomorrow is exams, right? By 12, before 12, I should be done. So you can decide to either continue your reading or you can just sleep and rest your head against tomorrow. Now we have another question here that says, in the synthesis of ammonia from nitrogen and hydrogen, given that Kc is 9.60, calculates now. This is the question, right? I'm just picking up the tough ones. Please, I want to solve the tough ones first. All right, the other ones I can just send the answer in the group chats, and of course you can check it out. So let's tackle the tough ones. So we have this question, class. This is under chemical equilibrium. So far, we have solved questions under chemical kinetics. With what I'm seeing here, they are setting the question based on chapters. The first three questions were under chemical kinetics, and chemical kinetics has collision theory. If you look at the last topics under the chemical kinetics, that's chapter 1 in CHM131, you'll see collision theory. All right. So the first three questions were under chemical kinetics, and this guy is under chemical equilibrium. So that means they've moved to chapter 2. Okay. Now, they are asking us to solve for Kp. Remember, there is a relationship between Kc and Kp, which means once I know the value of Kc, they said Kc for this reaction is 9.6. The temperature here is 300 degrees Celsius, which when you convert this guy to Kelvin, becomes 300 plus 273. That's 573 Kelvin. All right. Now, we are asked to solve for Kp. Now, somebody asked me a question and said, in cases like this, how are we going to solve it? Now, the relationship between Kp and Kc is Kp equals to Kc RT delta N. Now, this R is a gas constant. Class, if the R is not given to you, please make use of this. Don't use 8.314, except it is otherwise stated. So we're going to use this. Now, our delta N, class, this is gas. This is gas. Now, how do we get delta N? This delta N. Delta N is the difference between the gaseous mole and that of the gaseous reactant. So our delta N will be, the product is a gas. Yes. What is a mole? 2. Minus, the reactants are all gases. What are the coefficients? 1 for the nitrogen, 3 for the hydrogen. So that becomes 4. How do we get the 4? 1 plus 3. So 2 minus 4 is minus 2. So our delta N equals to minus 2. Remember they said we should solve for Kp, and they gave us Kc. So this becomes Kp equals to Kc into, okay, you come here. Anywhere you see Kc, you put 9.60 times 0.0821 times temperature is 573. Then delta N is minus 2. This becomes minus 2. Class, if you press your calculator, what are we going to get? So this is going to be, I will evaluate this guy first. I will evaluate this side first. So I would say 0.0821 times 573 raised to the power of minus 2 times 9.6. So the answer to this question is 4.34 times 10 raised to the power of minus 3. So that is the answer to that question. Okay. Now let's look at the next one. This particular question number 7, a lot of persons have been coming to my DM to ask me this question. So let's solve question number 7. Now question number 7 says, calculate the amount in grams barium sulfates that will be present in 25 dm cube Now, this is a question, a very technical question. A lot of persons have actually asked me to solve this question, but I'm glad I'll be solving it here. Now, they said calculate the amount in grams of barium sulfate, BaSO4, that will be present in 25 dm cube of water at 25 degrees Celsius, given the solubility product constant of this to be. Once again, what did I just notice here? This is still question under chemical equilibrium. Now this time around, it is under KSP. It is still under chemical equilibrium. So once again, they are doing it chapter by chapter. All right. This is question number 7. So between question number 1 to 7, we have seen chapter 1 and chapter 2. Okay. Now let's look at the solving here. First and foremost, KSP. First, this is barium. Now we're going to dissociate this guy. We have barium 2 plus SO4 2 minus. They're asking us to solve the amount in grams of barium sulfate. Now remember, when I treated this topic in class, there are 2 ways question can be asked. They can give you the molar solubility and you're asked to solve for the KSP. Or they will give you the KSP and you're asked to solve for the molar solubility. All right. Now, this time around, they've given us KSP, so we need to solve for molar solubility. After getting the molar solubility, we can now further solve the mass. So this is what we're going to do. I'll say KSP. I'll say we do not know the molar solubility of this. So we want to solve the molar solubility. Okay. We do not know the molar solubility of this. So we call this guy to be X. And since this guy is in a ratio of X, 1 mole of this gave 1 mole of this and 1 mole of this. So we do not know the value of this, so we call it to be X. Our sole aim is to get the molarity of this. After we've gotten the molarity, remember molarity equals to mole over volume. When we get the molarity of this, we are going to find the mole. Remember they gave us volume to be 25 dm cube, which is equivalent to 25 liters. So once we find the mole, we can now say mole equals to mass over molar mass. So we can now say mass equals to mole times molar mass. Now all of this, it looks bulky, but you can just use your calculator to do this. So let's proceed. So I'll say my KSP is barium 2 plus Class, in exam, this is not necessary because guess what? The number of lines given to us to solve this question is just one line or two lines. So all of this is not even necessary. You can even skip this. Once you see one line, solve it and just put the answer there. Right? This is not necessary because it's only one line they gave us. So just see how we're going to solve this. So I'll say, since I do not know the value of this, anywhere I see this, I'll put x. So this becomes x dot x equals to equals to the KSP, which is 1.5 times 10. So x times x is x squared equals to 1.5 times 10 raised to the power of minus 9. X equals to square root of 1.5 times 10. All right, so we want to find x. So what is the square root of? We now say square root of 1.5 times 10 raised to the power of minus 9. Now this becomes equals to 3.87 times 10 raised to the power of minus 5. Class, what we have here is molarity of barium sulfate, which is 3 point this. But remember, they did not ask us to solve for the molarity. They asked us for mass. So this is what I'm going to do. I will say molarity equals to mole over volume. Just watch out. I just want to solve everything at once. So this is equivalent to saying mole times 1 over volume. Because mole times 1 is mole all over volume. I don't want to write it all over volume so that it doesn't take time. Now, mass, mole. We know that mole equals to mass all over molar mass times 1 over volume equals to molarity. Now, this is what they're asking me to find. And guess what? They gave me the values to solve for the molar mass of barium sulfate. Okay? So we'll now say barium sulfate. We want to solve for the molar mass of barium sulfate. Barium is 137 plus sulfur is 32 plus oxygen is 16 times 4. So let's check that out. 137 plus 32 plus 16 times 4. So this is 233 grams per mole. So this is what we're going to do. The volume is already given to us in dm cube or liters, which is correct unit for molarity. So we're going to solve this guy directly. So we want to make this guy subject of the formula. All right. So this is more like saying, if I make this guy, if I make this guy subject of the formula, this will now become mass equals to molarity times molar mass times volume. Yeah, because this guy, if you now say this, mass times 1 equals to this times this. So what is our molarity? What we got here to be 3.87 times 10 to the power of minus 5. What is the molar mass of barium sulfate? 233. And what is the volume given to us there? 25. So this becomes times 25 times 3.87 times 10 raised to the power of minus 5. So the final answer is 0.225. Class, all of this is not necessary. What they need from you is just this answer. This is it. Because if you look at the lines, they just give us one line. How do they expect me to solve all of this in one line? So that is why you have to take maybe extra sheets or you use pencil and eraser so that you can solve on your white paper, your question paper, and also clean it off. So this is the answer to that question, right? So let's continue. Now this next question is under thermodynamics. So I'll solve this guy in a paper because it's looking very funny. Question number 8. I'll solve it in a paper. I want to confirm something. So to avoid making mistakes, since this is a live video, I'll solve it in a paper and I'll drop it after now. All right, I'm suspecting something about the question. But let's look at the next one. Remember, question number 8, I'll solve it and drop it. I just want to avoid mistake because I'm recording this guy, so I don't want mistake. So question number 9 says, predict the spontaneity of the formation of NO from N2 and O2 at 298 Kelvin. Given that now this particular question is under thermodynamics. So now watch, they have moved from chapter 1, chapter 2, and they are currently in thermodynamics, which is chapter 3 in CHM131. You can see the concept they are following, right? So I think I even guess the lecturers, they are getting tired of twisting questions. So they just want something that will also be easy for them. So they are setting it chapter by chapter. I just hope it continues like that. Now, in the last video I dropped, the very last video I dropped on that thermodynamics, I had already explained this. All right. So, but since it's part of the past questions and some persons may not have seen it, please you can check out the video after this. So I'm going to solve this guy. So we say predict spontaneity. Now, when they say something is spontaneous, class, it means that a spontaneous process or a spontaneous reactions are reactions that can occur on its own without the help of an external force, like something that has the tendency to happen or to occur without anything causing it to occur. That's a spontaneous process. Now, in thermodynamics, right, there are parameters that we can use to tell if a particular process or a reaction is spontaneous. And that parameter is delta G, that is Gibbs free energy change. Right? Now, what is the formula to solve for this? So this is delta G equals to delta H minus T delta S. Class, in this question, they are asking us to predict. So basically what I need to do is to solve for this guy, right? The answer of this guy will now tell me if that process is spontaneous. If delta G, if the value for delta G is less than 0, that is negative. It means the process is spontaneous. If delta G is equals to 0, it means the reaction is at equilibrium. If delta G is greater than 0, it means the reaction is non-spontaneous. So let's solve. Delta H from the question, they gave us to be 180.7 kilojoules. Temperature, they gave us to be 298 Kelvin. And delta S, they gave us to be this. So all we just need to do is to solve for delta G. But don't be in a haste. Do you know why? This value here is in kilojoules, while this guy is in joules. So we need to convert the kilojoules to correspond with the joules, or you convert the joules to be with the same with the kilojoules. If you don't do that conversion and you go ahead to solve, you're going to get a wrong answer. Right? Remember, our aim is to just see if the value is going to give us negative. So they don't need all this. From the question, it's just one line. They don't even need all this calculation. So You just need your calculator to just get the value of delta G. So when you convert this guy to joules, this is 18700 joules. So I'll now say delta G is delta H minus T. Unfortunately, my battery is low, so my battery, I'm streaming, so my Wi-Fi is connected. A lot of things is happening, so my phone is running low very fast. So if eventually my battery runs down, please, I'm going to encourage us to actually check our CHM131 playlist. Right? It's just it's just in our channel. All of this is there. If you actually can watch it, the topics you feel you have not covered, right? If you're on our group chat, I already listed out all the topics. If you're not on our group chat, please send me a message after this particular video. If you're not on our group chat and you want to join, please use my phone number. Send me a message and I will add you. Or alternatively, you can just check on our playlist, CHM131 playlist. Just select any video you feel you're lacking or you're lagging behind in that topic. Okay? Now, so let's come back to this. Now let's solve for delta G. So anyway you see delta H, I put 18700 minus T is 298 times, this is minus 24.7. Class, if you do your calculation, I already did this calculation earlier, we got plus 1733. Remember I said what you just need is your final answer. All right. Now, how do we predict? So after you have solved this, you now say since delta G is greater than 0, you now put plus 1733 kilojoules, or joules rather. Remember, if the answer is greater than 0, that is positive. It is non-spontaneous. Assuming the answer was less than 0, that is, we got a negative value. The process would have been a spontaneous reaction. Remember, they say we should predict. So after solving for this, and the value is greater than 0, it means it's non-spontaneous. So that process is non-spontaneous. Please, if you're getting value for this particular class this night, please just tap on the like button. At least let me know how many persons are really catching up or enjoy or have liked the class. Like if you're picking out value from the class, please tap the like button. We should actually learn how to tap the like button. Like button actually tells us, the creators, that okay, this video is doing well, and it also tells the YouTube that okay, this video is doing well. Okay, so please don't, if you're not getting value for this, please don't tap. I just want to know those that are really getting value, so it will encourage me to know if I will do something like this for CHM132, and also encourage Roland to do something like this for physics. So your like, sincere evaluation will actually go a long way. So the answer for this is the answer. Since delta G is greater than 0, the reaction or the formation of this is non-spontaneous. Now, but let me say this. If a process is non-spontaneous going forward, the reverse will be spontaneous. So if A plus B to give C, delta G is plus 5. This process is non-spontaneous because delta G is positive. But when I reverse this guy, it becomes negative. So if a reaction is non-spontaneous in a particular direction, when you reverse that reaction, it becomes spontaneous. If it is non-spontaneous, when you reverse it, it becomes spontaneous, and vice versa. Okay, this is under thermodynamics. So let's look at the next question. Remember, exams is tomorrow, so I'm being very fast. I presume that a lot of us, this should actually serve as a revision. Like I said, After the class, I'll drop the past question. So try as much as you can to complete it this night before you sleep. Anywhere I stop, make sure you complete it this night using our videos, because all the questions here, we have them in our video playlist. Now the next question says, now they have moved to electrochemical cell. They just jumped, but I'm sure they will come back. They just jumped. Oh God, these people think they are very wise. Now look at what they did. Now after chapter 3, they are meant to move to acid and base. But look at what they did. They went to chapter 5, right? They went to chapter 5 and brought question, just one question, put it, and after their particular question, they revert back to following the particular series so that it will not look as if they are doing it chapter by chapter, right? Question 1 to 7 was chapter 1 and 2. Question 8 and 9 is chapter 3, Thermodynamics. Question 10, they went to bring electrochemistry. That is the last chapter. Just one question. And after that question, 10, 11, 12, 13, 14, 15, 16 is acid and base. 7, acid and base is the highest. Acid and base had the highest number of questions. What is this telling us? That after this video, when you want to revise, please look at acid and base because it has lots of topics. That doesn't mean you should actually stick only to acid and base. I'm actually telling us what I noticed here. Now let's look at the question. It said, let me be sure my phone is not off yet. Oh. So they said, in let me just read the question, class. The question says, in an electrochemical cell, the medium through which ions can pass, a medium through which ion can pass that is usually filled with KCl or KNO3 is dash. In an electrochemical cell, the medium through which ions can pass that is usually filled with KCl or KNO3 is called dash. In a gelatin, I repeat, in an electrochemical cell, the medium through which ions can pass that is usually filled with KCl or KNO3 in gelatin is called dash. Class, the answer is salt bridge. Take note of that. A salt bridge is a medium that connects the two electrodes of a galvanic cell. It connects the anode and the cathode. Now, as the word implies, salt bridge, KCl is a salt. This is a salt. So it contains salt inside of it, right? That bridge the two cells. That's why they call it salt bridge. A bridge is something that connects two parts, right? So it connects the anode to the cathode. And what is it made up of? A salt. That is why it is called a salt bridge. Now the next question says, pH, please, the pH of a weak acid. I've already done that. Check our videos on pH and pOH, right? You're going to see that. The next one is conjugate acid and base pair. Conjugate acid and base pair. Now let me explain that one. They said, give the conjugate base of each of the following. Give the conjugate base of each of the following. For the fact that they are asking you to give the conjugate base of this, it means that this is an acid. A conjugate base is formed when an acid loses one hydrogen. So remove one hydrogen from here, this becomes HSO4 minus. Why are we putting minus? Because hydrogen is going out as H plus. Hydrogen is going out as H plus. So if plus will go out, minus will stick back so that when you add it, you can neutralize it. So this is a conjugate base of this. And for this guy, This is the conjugate base of that guy. Okay. They said the color of bromophenol. Please, this particular one, I will not lie you, I don't know the color of those indicators. The only indicators I'm very conversant with is methyl orange and phenolphthalein. This one they said bromophenol blue and thymol blue. Please, I will not lie, I don't know it offhand. So I'll actually advise us to check it out. Bromophenol blue and the question says, what are their colors? Please look it up so that in case you want to repeat this question, look up the color of bromophenol blue and thymol blue. I don't have the color of this offhand. The only one I have offhand is phenolphthalein and methyl orange. So just check up the colors of acid. Phenolphthalein in acid is colorless, right? I don't want to comment. So this one, I'm very certain about this one. Please just look up the colors of indicator online. Just do it after this class. You can just phenolphthalein, methyl orange, methyl red. Please, these are the indicators. Please just look up this. Check their colors in acid and basic medium. Phenolphthalein, methyl orange, methyl red, bromophenol blue, thymol blue, and bromocresol. Okay, I'm very scared. I'm very, very scared. This is 10:40 and my battery is low. So this is what I'm going to do. I would like to really continue so I can assist us. So while I want to actually charge my phone because my mic adapter is plugged in where I'm supposed to plug my power bank. And if I should remove this mic, it's going to be echoing because my fan and some other appliances are on. The house is hot, so I need to calm it down with, So if I remove the mic, the noise from all the appliances will actually interfere with the videos. The video, do you get? So I'll actually end this video now, and then I'll come up. This is 10:40. By 11 o'clock, I'll try and power it for 20 minutes, and I'll let us know so that if you're still awake, you can join us. But I don't expect you to sleep by now. So what you just have to do is I'll actually share the past questions on the group so that you look at what I just said now. They are setting the questions chapter by chapter. So when I posted our videos, I made it chapter by chapter. For those persons that viewed or watched those videos I posted chapter by chapter, kudos to you. For those that have not, please check on our playlist, watch it chapter by chapter. All of this, I have treated it. All. This class is just supposed to be a bonus. All right. So I'll actually go off now and I'll power my phone. By 11 p.m., please come on YouTube and type Delzy online. By 11 o'clock, come back on YouTube, search this. Once it comes out, if I'm live, you're going to see a red circle around my DP. There will be a red circle around my DP. So just tap it, I'll be live. So thank you very much for encouraging me to do this video. See you guys by 11 p.m. Thank you.